Let us evaluate the integral of cotangent to the power 6 of x. When dealing with an integral of cotangent and your exponent is an even number, you would first need to factor out 1 cotangent squared of x, making this cotangent to the power 4 of x multiplied by the factored out cotangent squared of x, and copy the rest, which is just dx. And the next step would be to transform the factored out cotangent squared of x into its trigonometric identity. Cot squared of x would be equal to cosecant squared of x minus 1. Next step would be to just substitute that. Cotangent squared of x would be equal to this one. And the next step would be to distribute cotangent 4 of x among the parentheses. The next step would be to split the integral into two parts. First one would be the integral of cotangent 4 to the power 4 of x multiplied by cosecant squared of x, and of course distribute the dx. Minus, since it is a negative sign, the integral of cotangent to the power 4 of x of dx. And for the next step, let us focus on the first part first. Let u here in this case be cotangent of x, just for the first part, and take the derivative. The derivative of cotangent of x would be equal to negative cosecant squared of x of dx. Isolating the x, you would have a value of du over negative cosecant squared of x. So for this one, it would be the integral of u to the power of 4, since cotangent of x is u, multiplied by cosecant squared of x, and multiply it by the x's value, which is equal to negative du over cosecant squared of x. You can see here that cosecant squared of x would cancel, leaving you with a negative du. And you can actually put the negative sign outside the integral. Which makes this negative integral of u to the power of 4 of du. Take the integral of this one, it would be negative u to the power of 5th over 5. And don't forget, and it is not yet necessary to add plus c because there is another part of the integral. And so for the integral of this one, it is equal to negative u to the power of 5 over 5, or u here in this case is cotangent of x. So it would be equal to negative cotangent of x to the power. Let us just write this way, negative 1/5 cotangent to the power 5 of x. Now that we have done this one, let us focus on the second part for the integral. We can now erase this one. For this one, you can see again, we have an integral of cotangent and our exponent here is an even number again, just like this one. So same rules. Factor out 1 cosecant squared x again. So this would be negative integral of cotangent squared of x multiplied by the factored out cotangent squared of x of dx. And once again, transform cotangent squared of x according to its trigonometric identity. and to distribute cotangent squared of x among of this. And you can see here again that we must split the integral into two parts again. For our first part, it would be negative integral of cotangent squared of x, cosecant squared of x of dx. And for the second part, you can see here that we have a negative and a negative in here, which makes this positive integral of cotangent squared of x of dx. Now that we have that, just like with this one, let us focus on our first part again. Let u here again be cotangent of x. Taking the derivative of this, it would be equal to negative cosecant squared of x of dx. Dx right here would be equal to du over negative cosecant squared of x. Just for the first part once again, this would be negative integral of u squared multiplied by cosecant squared of x, and dx right here is equal to negative du over cosecant squared of x. You can see here again that cosecant squared of x would cancel again, which leaves you with u squared multiplied by negative du, and you can put the negative sign outside the integral, which makes this positive integral of u squared of du. And taking the integral of this, it would be equal to u cubed over 3. Or we can put this as 1/3 multiplied by u to the power of 3. And u here again would be equal to cotangent of x. So this would be cotangent to the power of 3 of x. So now that you have that, we can now integrate the last part, which is the integral of cotangent squared of x of dx. And for this one, we cannot factor out one cotangent squared of x anymore because it is what is left now. And thus we can now split, or I mean transform this into its trigonometric identity. Let me just put it in here. So this would be the integral of cosecant squared of x minus 1 of dx. And for this one, we can now once again split this integral into two parts. So this would be the integral of cosecant squared of x of dx minus integral of 1 of dx. Focusing on this one, the integral of cosecant squared of x. What you must know here would be this one. The integral of cotangent of x would be equal to negative cosecant squared of x. And since we know that the derivative would be the opposite of integration, we can say that the integral of negative cosecant squared of x is actually equal to cotangent of x. But since what we have here is a positive cosecant squared of x, just reverse the sign. So this would be negative cotangent of x. So this would be the integral of that. And for the last one, the integral of 1 dx is simply x. And for the last one, the integral of 1 dx would be simply x plus c, making this your final answer.